Welcome back. So in last part we are discussing about the observation and the inference of the Rutherford model, Rutherford experiment. This was a Rutherford experiment and we are discussing the observation. So we are in the large scattering angles. We are discussing about the large scattering angle, what was the reason behind this. So as the overall mass, as according to Rutherford, as the alpha particle was deflected around 180 degrees, sometimes very rarely, but it was deflected, and also in some cases greater than 90 degree. So deflecting in a large amount, large scale, the heavier particle, alpha particle, indicates that the nucleus for which the alpha particle is deflecting in the huge scale, huge amount, that mass of that particle should be heavier. Otherwise this is not possible. So that, and also from the previous observation, it was evident that the overall space inside the atom is actually the empty space. Most of the space is the empty space, and the presence of electron also there. Now Rutherford says that there must the overall mass of the atom should be centered at a point which is a positively charged point, and that is called as nucleus, like this. This was the Rutherford's justification of this observation. Rutherford said that these results actually confirm the presence of the nucleus. There's a strong electrostatic repulsion between the alpha particle. Why the repulsion? Because the electron is the alpha particle is also positively charged particle, and nucleus should be positively charged, otherwise it will not compensate the negative charge of the electron. And the nucleus is positively charged particle. Okay, it is proved. So now if we analyze this result, the result of the scattering, the theta, these things, then we obtain that the diameter, the radius, not the diameter, the radius of the atom should be 10 to the power 10 meter. This is the diameter, sorry, not the radius, diameter of the atom. Okay, atomic diameter is 10 to the power 10 to the power minus 10 meter. It was known to us, and the Rutherford experiments suggest that the nucleus should have the diameter around 10 to the power 14 meter. So which essentially indicates that the nucleus is 10 to the power 5 times smaller compared to 10 to the power 4 or 5 times smaller compared to the overall atom. That means the nucleus centered in the atom, occupying the space 1 in 1000, 1 in lakhs, actually 10 to the power 5, that means 1 lakh. So if this is an atom, the nucleus is only considering the covering the space 10 to the power 5 times. That means we can say this is much more like, okay, so like this. So the atom is 10 to the power 5 times bigger compared to the nucleus. So from this data we can assume that we can think that how small the nucleus is, and in this nucleus the overall mass of the atom is centered, because electron is very lightweight particle. The mass of the nucleus is negligible compared to the electron compared to the mass of the electron is negligible compared to the mass of the nucleus. So we can say that the most of the mass is centered in the nucleus. Okay, so as we know, the alpha particle is actually, it was discovered later that this is actually the helium-242 plus. This is the alpha particle. Okay, so we will discuss that later, but from here we can say that the interaction between the alpha particle and the nucleus should be Coulombic, and the force acting, the repulsive force, it should be like this, 1 by 4 pi epsilon 2e, because alpha particle is, there is 2 plus. This was the helium, this thing was not known, but the mass and the charge of the particle, alpha particle, was known. So it was twice of electron. It was known at that time. So we can write the 2e, this is the charge of alpha particle, and Ze. Ze means the Z is the atomic number of the gold, the nucleus, because we are taking the gold foil, right? So the nucleus should be nucleus of the gold, which should have the Z. The charge is Zd, then E is the charge of electron and Z is the number of number of proton. I am not getting to that, but the mass should be Zd, charge should be Zd, and this is the R square. So this should be the interacting force between the alpha particle and the nucleus. So I am not discussing that because this is the proton constant is there. Okay, so the Rutherford model was that, according to that observation, from this observation Rutherford gave its model, the Rutherford model, which says that in center of the atom there is nucleus. In the nucleus, the most of the mass of atom is centered, and around nucleus the electrons are revolving. Okay, like this. This is the nucleus, and around the nucleus the electrons are revolving like this. So this is the Rutherford proposed model. Okay, this was the Rutherford proposed model. Nucleus is very much heavier compared to the electron. So this Rutherford model was oftenly compared with the atom, the solar system model, but there are some similarities is there, but still there is very much dissimilarities, which proves that this is not actually identical with the solar system, but we can study that, we can discuss that. The similarities between the solar system and this Rutherford atomic model was like the sun. In the solar system, the sun is centered, okay, and the planets revolving the sun. Like here also the nucleus is in the center and the electrons are revolving around the nucleus. Also, the size of sun and the mass of the sun in the solar system is much more heavier compared to the planets. Here also the size of the mass of the nucleus and the size of the nucleus also is much more heavier than the electrons. Okay. Also this overall, if we consider the overall solar system, okay, not the size is not the correct word, the mass is the correct word. Actually the mass of the electron is negligible compared to the mass of the nucleus. Just likely in the solar system, the mass of the planets is negligible compared to the mass of the sun. Okay, also the most of the space in solar system is also empty. Here also the most of the space is empty. So these are the similarities, but there are lots of dissimilarities, like that in the solar system the planets are rotating around the sun due to the gravitational force, we know that. But here the reason behind the revolving, the electron is revolving around the nucleus due to the total electromagnetic interaction. The force is the electromagnetic force. So this is the most of the important dissimilarities. Also in the solar system model, we know that in solar system, in one orbit only one planet can present, but here in one orbit more than one electron can be there. More than one electron can be there. Here is 2 electron, even there should be 30, there may be 32 electron. We will study further. So this is also dissimilarities. Also the planets in the solar system all are not in the same size or not in the same kind of planets. The size of the planets, the mass of the planets are different, but here the all electrons are indistinguishable, you can say that. So these are the dissimilarities. So also later we will see that this Rutherford atomic model is also not the correct model, we can say. There are some drawbacks, we will discuss these drawbacks, but Rutherford gave this model. This nucleus basically contains, so we can okay, let me say, according to Rutherford says that if there is Z number of electron in the atom, we can say that the number of electron, because in case of gold Z was I think 79, this atomic mass. So from there we can say that the Z is let us say there is Z number, I am not getting to gold, for a general case Z number of electron is present in the atom. So, the charge of total charge of the due to the electron should be minus Ze, because charge of the one electron is minus E. So, total charge should be minus Ze, and overall electron is neutral, overall atom is neutral. So, the charge of the nucleus should be plus Jd. This should be plus Jd. That is why Rutherford says that in nucleus there are Z number of positively charged particle, which was called proton. Rutherford gave the idea of proton. Z number of protons should be there. The charge of the proton is the same of the electron, but the mass of the proton is much more heavier compared to the electron. So, Rutherford says the electron is minus 1 0 and proton is plus 1 1. This was the model of Rutherford. That means there is a nucleus. Nucleus means the bunch of proton. In the nucleus there is Z number of proton. If the Z is, let us say, 10, if we say according to Rutherford, then 10 electrons are revolving around the nucleus, and nucleus is basically the bunch of 10 protons. That is the nucleus, which is the positively charged, and the charge is Z times E. Here it is 10E, and the total charge of the electron also 10E. That is why the overall atom is neutral atom. So, this was the Rutherford atomic model. Rutherford gave the idea of the proton. Thomson discovered electron, Rutherford gave the idea of proton, and it should be, because there should be some positive particle. It was trivially I said the positive particle is there, there should be. This was not very new thing, but this is the new thing. The space occupying by that positive particles is very less compared to the total space of the atom, total size of the atom. The most of the space is empty inside the atom, and electrons are revolving around that bunch of the positively charged particle, which is called nucleus. This is some new things was proposed by the Rutherford, and this was great we can say this, though there are some flaws, but as a preliminary model, this is an excellent model, that is why Rutherford get the Nobel Prize. But what was the flaws? What was the flaws or drawback? There are mainly two drawbacks. First is this: according to the classical theory of the electromagnetism, we know that if there is a charged accelerating particle, then that particle should emit an electromagnetic wave. We have discussed this. If there is some accelerated charge particle, it should emit some electromagnetic wave. So, as nucleus is steady according to Rutherford, and now electron is revolving in a circular path, which is called orbit. Okay, this circular path in which the electron is rotating, this is called orbit. In case of planetary motion also you know this. So, electron is rotating in this path, electron is a charged particle, and when it is rotating around a circular path, so that means there is the acceleration, angular acceleration should be there. So, there should be some emission of electromagnetic waves. Now, when an electromagnetic wave is emitting, that means the energy of the electron should be decreasing with time, and the path of the electron should be like this. It should be like this, follow this path. That means that you can say that since the orbiting electrons are accelerated, it should be accelerated because it is following a circular path. This should also emit some electromagnetic waves, and as a consequences, if this happen, the energy of the orbiting electron would keep on decreasing. It would follow a spiral path. This is a spiral path. I should draw it properly. Okay, let it like this. This is a spiral path. It should follow a spiral path, and it should collide ultimately in the nucleus. It should be okay, but it's not happening, because if it is this case, the case should not be like this. Otherwise, the atom will not be stable. If electron getting collide in the nucleus, then the overall structure of atom will be collapsed. and if atom is not stable, in that case overall matter will not be stable. But we can see around us every matter, everything is totally stable. It is not any collapse we can see. So we can say that this is not the case. Electron is not colliding in the nucleus, this for sure. If we calculate the time scale, this time scale should be 10 to the power minus 8 second. So we can say the atom is stable for 10 to the power minus 8 second only. So it's not the case. So we can say this is the drawback. The Rutherford model cannot explain this. Why the electron is not coincide in the nucleus. Okay, so this is the main drawback. Also, there is one more important drawback, the continuous, not the continuous, we should say the line spectra. We are discussed in the very first part of this lecture, we are discussing about the atomic spectra, right? In atomic spectra of the hydrogen atom, we obtain like this. We will discuss in detail this thing, atomic spectra. In atomic spectra, we obtain, there is some line spectra of like this. This is not the continuous spectra, this is some line spectra. But why? Why there is some particular wavelength of the frequency? If this is lambda, that means for some specific lambda there is a line, there is some absorption or emission. We will discuss in detail that. But for some specific lambda, not for any lambda, it is not explained by this Rutherford model, because according to Rutherford model, electron can rotate the nucleus in any orbit. There is no restriction. The orbit can be anything. So if the orbit is arbitrary, there is no restriction in the orbit, then there should not be any restriction on the emission spectra, atomic spectra of the hydrogen atom. Okay, so there should not be any line like pattern in the lambda, specific lambda, why the specific lambda is chosen. This is not clear from the Rutherford model. Rutherford model can't explain this. So instead of continuous spectra, we obtain the line spectra. Okay, so according to Rutherford model, as electron is orbiting the nucleus and it is a charged particle which is accelerating, so it should radiate electromagnetic waves. That's correct. For which we should have some spectra, but that should be continuous because it's continuously rotating. So it should be continuous. And also there is no restriction of the orbit. So orbit can be anything, any diameter, any radius is allowed. So in any lambda we should have some spectra. The intensity may be different, but the specific lambda is only chosen in the atomic spectra. In atomic spectra, for specific lambda there is some line, for other spectra, other lambdas there is a dark, there is no line actually. So from this observation we can say this, the line spectra structure is not consistent with the Rutherford atomic model. These two are mainly basic drawback which was explained basically by the Bohr's postulate. We will discuss in the next class. So let me stop here in this class. So in this class we discuss the Rutherford. First we discuss the Dalton theory. Dalton theory was Dalton hypothesis. After that, the discovery of the electron, which proves that atom is not the indivisible part, there is some electron. And after that we discuss the palm pudding model, not in detail, just we gave the idea of the model. And then we in details we discuss the Rutherford atomic model, the experimental setup, then we discuss the experimental observation, and we discuss the inference of this observation, and that understanding we discussed, we get the idea of the atomic structure of given by the Rutherford, which was like this, and we discuss about the concept of proton, how it was appearing, and at last we discuss the drawbacks of the Rutherford model. And in next we will continue from here and we will discuss the Bohr atomic theory in the next class. Let me stop here. Thank you for your attention.